Hello, this is Brett Ethridge, founder of Dominate the GMAT, here with an important GMAT data sufficiency tip for you. Here you see the question that we're going to be looking at. Is X a negative number? Right? It's a yes-no question, and you can check out some of my other videos for some tips on yes-no questions. But the tip for today has to do with making up numbers, and it seems like a very simple tip, but it's something that I think a lot of students don't always think about. And the tip is this. You know the strategy when you see a variable on data sufficiency is to make up numbers for those variables just to see kind of what happens with the problem, and you can try different types of numbers for the variables. But the tip is this. You can only use numbers, you can only make up numbers such that the statements remain true. And here's what I mean by that. What could X be in each of these two statements? Well, in theory, X could be anything in the world. However, the statements restrict the possible values of X. And so you can only choose numbers for X that actually satisfy the statement, that allow the statement to remain true. We can't alter the truth of the statement. That's kind of what guides us in these types of problems. So that's the tip, and it takes a little bit of practice. Let me show you what I'm talking about here. Let's work through this. You're going to evaluate statement number one in isolation. First things first, let me draw up the kind of the mock answer grid that you always want to do when you're scratch paper, so that as we make a determination about the statements, we can eliminate answer choices accordingly. And as you know, when we're going to be doing this, we want to figure out what are some possible values of X, because depending on what we determine and learn about the nature of X, that'll enable us to answer the question. So what could X be? Could X be 1? X equals 1. Could X be 1? Well, in theory it could be, but the statement requires certain things about X. Statement 1 has to remain true. And if X is 1, right, then what we have is 9 is greater than 10, which is a falsehood. That's actually factually incorrect. 9 cannot be bigger than 10 ever in the history of math. And therefore, 1 is not an allowable value for X. Got to try something else. Well, what about 2? Could X be 2? Well, then we kind of have the same problem, right? We'd have 18 is greater than 20. Again, incorrect, false, not allowed. Therefore, 2 cannot be an allowable value of X. Does that make sense? So when you're thinking of possible values for X, it actually helps shape our thinking. Well, what might actually change this? Fractions, no, positive fractions are going to work the same way. Could X equal 0? Well, if X is 0, 0 is greater than 0, that's also factually incorrect. What about negative numbers? Could X be negative 1? If X were negative 1, then what we would have is a situation where we have negative 9 is greater than negative 10. Is that a true statement? Think about our number line, right? Our number line, when we're on the left side of it, when we're talking about negative numbers, right? Actually, negative 9 is in fact further to the right, further positive. I.e., in fact, negative 9 is greater than negative 10. So negative 1 is an allowable value. And you can continue to test numbers this way, but what you're going to find for statement 1 is that only negative numbers, in fact, allow that statement to be true, which is why statement 1 is sufficient. And remember, once we determine that statement 1 is sufficient, we can immediately eliminate B, C, and E. And let's do the same thing with statement number 2. Again, the tendency of some students is to just make up random numbers for X, right? Well, what could X be? Again, X can only be something such that statement number 2 is actually true. So could X be, I don't know, 2? Of course, because 2 plus 3 is positive, for sure. Could X be 0? Yes, because 0 plus 3 is positive, so that's an allowable value. Could X be 1,000,000? You know, of course, because 1,000,000 plus 3 is positive. But here's where it gets interesting, right? As we teach, you want to try all different types of numbers. You want to try fractions. You also want to try negative numbers. Could X be negative 1? Yes, because negative 1 plus 3 is positive 2, which is positive, that is a true statement. Therefore, -1 is an allowable value of x as well. And you can continue that way, right? But what can't it be? It can't be anything less than 3. Does that make sense? Because if x is -3, or sorry, less than -3. If x is -3, -3 plus 3 is 0. Is 0 positive? No, 0 is not positive. So anything less than or equal to, so less than or equal to -3, x cannot be. But we've learned enough to actually answer the question, right? Because is x a negative number? Well, we don't know. We've determined that x could be something positive like 2 or 1,000,000. It could be something negative like -1, so we're not sure. Is it a negative number? Maybe yes, maybe no, according to statement number 2, because we chose values for x such that statement 2 remains true. So these are all allowable values of x, except for -3. And therefore, we're still indecisive. We're not quite sure. Therefore, statement 2 by itself is not sufficient, which is why the correct answer is answer choice A. So that's it. Again, it seems pretty straightforward. The tip, of course, number 1, always try to make up numbers for variables to kind of see what's going on. Try lots of different types of variables, but make sure the variables you're testing are true. You can only choose values for x such that the statement actually remains true. And with this, I think data sufficiency will be a whole lot easier for you, better equipping you to go out and dominate the GMAT.